Okay, so hi everybody. We left off yesterday or last week from segmenting the left coronary artery with the model, and this week we are gonna segment the aorta and try to reconstruct the model with the aorta included. So Anna is gonna take the lead on this. So Anna, you can start segmenting.
Um, So I think the students are pretty familiar with this because they're going through the same pipeline for their labs as well. So there shouldn't be that much of a issue with this one. I will just quickly go through the aorta so we can see the aortic valve here. And, this is where the right coronary tree is coming out of the aorta. So we need to capture that. I will go a little bit lower than that. So let's place and just turn on the plus. Pictures. And this one. And try to keep it in the center of the aorta. So we created a path of this, and I will move on to the segmentation. Let's create a configure. The path that I select is aorta. And you can change the size of the window it is showing. Let's change it to 25. Maybe it's not enough, maybe 50. Okay, much better. And for the aorta, we can still use the circle, but let's this time use a polygon. I will place it on the borders of the aorta.
Anna, just a quick question. So when you place the polygons, should we smooth it as well? I know there's a smooth function because
Yes, there's a smooth function. Yeah. Yes, we
oh
can try smoothing as well. You're right.
yeah, we should do that, I guess, because the other ones are
Mm.
too choppy. What I also used to do was use like threshold for the aorta. Uh, can have you
Well,
tried the threshold?
no, basically because I usually segment aorta 3D. I've never tried it actually on vascular.
Oh, you have never tried it. Okay, let's do 2D. Can I try take over a little bit for 1 second?
Yes, sure. Sure.
This is what I remember. So I would take a threshold, place it on. It's not working. Let's click it again. Threshold. Oh, doesn't seem to be working. Maybe it was level set. Nope. Uh,
So,
Let me see. Yeah, level set. So I would
oh, okay.
level
Interesting.
set, and then you can convert into spline poly. spline poly, and it gives you control. So if you click it, then you can kind of move these around if you like. So this is much more smoother. So we can go up and then do another level set, and kind of puts everything there. You can do
Your
swap.
audio is a little bit muffled, and it's hard to understand. I don't know if you got farther away from your mic or something.
Oh yes, I am on the other computer. Maybe that's why. Can you hear me better?
Yeah.
Okay, okay. So we can try another cross section. So these are pretty easy for level set to segment. You just click here. So you can click level set. And this one is a little bit bigger, so I'll make it a bit smaller. I can click spline poly, so you have a bit control. And then you can keep, I think, like 4 or 5 sections is okay. So I'm gonna put level set one more time. Oh, yeah, this is maybe too big. Make it a bit smaller. And then we can do the last cross section, like right here. Let's see this one. Level set. Oh, okay. And make it a bit smaller. And then I can do a lofting preview. It gives you a decent loft. I think the 3D one looks much nicer, which and I can show maybe in a little while. This is probably not the, yeah, we can take out this cross section. This one looks a little bit weird. I think this is probably, yeah, the good starting point for the cross section. Okay, so this is your,
Does it include the right coronary,
oh, the right
the
one is,
stem of the right one?
yeah, right coronary. Yeah, okay, we're gonna miss the right coronary. Okay, let's try it here. Maybe I'll go to the aorta path line, because this one, first aortic path line inside. Yeah, this one is, I would like to place it maybe the first one right here in the center. And then let's do the aortic segmentation. Maybe it's a little, yeah, this one looks a bit nicer, because then we are right in the center of the valves. So let's do like this one. I'll do a threshold, level set, sorry. Click here, click here. Yeah, this one looks a bit nicer, similar to what I would expect from a 3D. We can also do one level set right here. Yeah. Yeah, I think this is okay, right? I
Yeah.
think that as close to as, because 3D looks much nicer. So and I can show you a 3D segmentation for aorta, because aorta is big. You can actually do a 3D segmentation. Um, let's see if you want to remove. Actually, I don't like this slanted one, so I'm gonna do a new one that's a little bit nicer. Yeah. Oh, maybe this is probably not the best one, because it's like if you do a 2D segmentation, what ends up happening um is something like this, right? You see this edge coming out. So this is one of the reasons why we don't like 2D and 2D segmentations for aorta, because there's a bifurcation of left coronary artery coming out, and the 2D segmentation doesn't look well in this scenario. But nonetheless, let's put one above the ostium. Let's see how that looks. Okay, this one. Yeah, once we start smoothing it out, maybe it's gonna look better. But as you can see, the cross section looks yeah, so the cross section, we have kind of captured the cross section as much as we can throughout the aorta. the tricky part is when the LED comes out where you have this jump, right? So you don't want to have a cross section here because it's not gonna look nice. Okay, so you have all of this. Now you can kind of build your 3D model, build your model again. So you can come back to your model. You can say in your model, I want to include the aorta. So you can say, come here, create a model, and you want to say, I want to include the aorta now. So you have another surface you want to include, and you press OK, and hopefully everything lines up, and then you have your STL model with the aorta, right? So you can see you have the full STL model with the aorta with all of the walls individually labeled. And then you have the cap for the aorta, all of the caps, wall for the aorta. Oh, this one, I have to turn this off. Yeah, now you can see. Off. Now you can see, we can select all of the different walls. Okay, so now Anna can show you how to do. Anna, does it look good enough, or should we be doing 3D, or should they be doing 3D?
We can give it a try, maybe.
Yeah,
Yeah, I think we can do that in 3D slicer if you.
yeah. I just don't want to. I think for now we should just stick with 2D. And then
Okay.
once they're more comfortable, we can come back to doing like a 3D segmentation. Okay, so we have the LED, we have the aorta, so, and they can do the right coronary artery. I think, what else do we want to teach them? We also want to have them learn how to do the, are you all okay with segmenting the right coronary artery, or do you want us to show how to segment the right coronary artery as well? Any thumbs up for right coronary artery? If none, then we can move on to other stuff as well.
I think I'm good to move on, but if others want, we can do it.
Okay. Okay. So Ravneet, are you saying you want us to show the right coronary artery, or you're okay to move on?
Sorry, I don't know if it'll take too long, but if you could just show it a little bit.
Yeah, that's not a problem. Okay.
Okay, thank you.
Okay, so let's start with the right coronary artery. So we're gonna build the path for the right coronary artery. So I'm gonna come back to my.
It's already there, the path.
So sorry, Anna, did you say something?
We already have the paths for right coronary artery.
Oh, we have the path for right coronary. Did we do it last time?
Yes, you did it the first session.
Okay, we did the, okay, actually we did do the right coronary artery. So same thing, we can do the right coronary artery segmentation. So create contours. I'm gonna pick the main RCA. I'm gonna start building my paths. So you want to make sure that your first cross section is inside the lumen of the connecting artery. So if your RC is coming out of the aorta, you want to make sure that your first lumen is inside the primary vessel, which is the aorta. So I'm gonna place just a circle here so that it's coming out of the aorta. I'm gonna make this, I'm gonna make the RCA size, 0.2D size, like maybe 2 is a good size. Okay, so we have the first cross section, then we can move on, do the next few ones. So I'm gonna do the next one, circle. Let's do one here. I can play around with my intensity. I don't like, yeah, this looks a little bit better. Then I usually tend to copy this, and then I kind of paste this and modify it as much as I want to. So I'm gonna paste this right here. Make it a bit smaller. Right, and then let's keep going. So you can see, so you want to look out for if there is any stenosis or narrowing, right? So in this case, and you might think this is a bit oval, but it's actually really not. It might just be an artifact of the imaging. Typically, I wouldn't expect it to be oval. One reason why you might be seeing it as oval or an ellipse is because there's a bifurcation coming out, right? If you look in the top image right here, then there's a bifurcation coming out, so that might cause the geometry to not look. I'm going to paste one here. So I have one right here, and then I'm going to keep going, paste one right here, make it a bit small. Oh, oh,
I'm sorry, I think I moved my.
yeah, I think because you're logged in
Yeah.
with viewer as well. Okay, so I'm going to keep going, paste, make it a bit smaller, paste, make it a bit smaller. Oh, there's a bifurcation. We're going to take care of that later. I'm going to paste and make it a bit smaller. I'm going to copy this. So as you're segmenting, you just want to look out if there is some kind of narrowing that, you know, that, or maybe a plaque. I don't know if you have talked about, Anna, did you talk about plaques, or did you see any plaques in the LED segment last time?
I think we mentioned the blooming artifact last session.
Okay. Okay, but if you guys see something that's really bright, then please let us know so we can help you to segment those ones as well. I haven't come across any plaques in this one. But if I maybe we should show one case where there is a bit of plaque so that students can better appreciate how to segment the plaques. Let's see, paste. And paste. I'm going to make it line up, make it a bit smaller. And copy this. As you move away from the heart, or as you move away from the ostium, you can see the lumen is getting smaller, right? Lumen is, the coronary arteries are getting smaller as they approach more distally to the myocardium. And it's also your I think this is it. Let's loft it together, right? Looks nice. Looks pretty nice to me. Okay, so this is my RCA 0. I can do my next RCA, create a contour group, my RCA 1. And similar to RCA 0, I'm gonna start inside the lumen, right? So this is my RCA 1. This is a vessel AV. It goes to the AV groove, or it goes to the atrium, right? Right, Anna? Or
It's fun, yes, it goes to the atrium. This is RV.
oh, okay. Let's see. Let's see. I'm gonna start inside the lumen. So make sure your lumen, it's not coming out of the lumen. And if you do this, you won't be able to mesh or model. It's gonna give you an error. So you gotta make sure your first lumen is inside. First segmentation is inside the lumen of the primary branch. And then you can start segmenting. So I'm gonna put a paste. Just have a circle. Okay, and then I can keep going. Paste. A bit smaller. Paste. paste. Make this a bit smaller. I think this is probably the right lumen. As you can see, as the lumen gets smaller, the image gets more blurry, and that's just because of the resolution of the imaging. So let's see, we can start segmenting this one. Move this here. Paste. It's just hard to see it. Okay, so let's look at this lumen. Yeah, it looks all right to me. Yeah, I'm okay with this one. Okay, let's do the last one, which is your RCA2. And yeah, so this is, let's do this one then. Create contour group. And let me turn this one off. RCA2, and just like before, we want to make sure it's coming out of the main branch. So I'm going to zoom in, paste my first lumen right here inside the original lumen, and then I can start building out. Yeah, this is really small. It's going to be a bit tricky to segment this one, but that's all right. We can do it. Let's keep going. This is hard to see here, isn't it? I don't even know if I can see anything. Are you seeing something?
No, it's really hard.
Yeah, this is really bad.
Mhm.
Yeah, it's almost yeah, it's really hard to see. Okay, I'm just gonna draw a lumen. Hopefully it's not that bad in your case. But I would say if you can't see the lumen, we shouldn't include it. I'll just not include it because it doesn't make sense. If it was really that bad, then we shouldn't include it. Okay, so we have the aorta RCA1, and then we have the RCA2. So this usually this would be the PDA branch, or Anna, is this the PLA or PDA?
This PDA, yes.
This is the PDA
Yeah,
branch.
it should be PDA.
So we should name it PDA, or what's the naming convention we're using? We call it
R_PDA_0.
yeah.
Actually, we forgot to add the L and R underscore for like all of the branches.
Yeah, so you should rename these to L_, oh, sorry, we should rename this to L, which means it's from the left coronary tree. It's the diagonal first diagonal branch, and we should name this, rename, we should call it L diag 2. We should call this the LAD branch. This is also on the left side, the LCX branch. And then we have the RCA. So this is the primary RCA branch. So I'm going to call it, what do we call it? Our right RCA?
R_PL0.
This one is PL? Oh, because
Yes,
we clip it out afterwards, right?
correct, yes.
So PL is 0. This is no, what do we call this? And is it
This is no myo,
no myocardial? Is that how?
yeah, no underscore myo underscore 0.
Okay. Because this doesn't supply to the left myocardium, so we just ignore this one. And then this one we are not including, but if this was to be included, we would call it R underscore P PDA
Yes,
0. And then this is your aorta. So we should rename all of these as well. Rename left score left underscore left underscore left underscore. This is our aorta, and you should all be familiar with this one if you're taking my course. This one was RPLA, right? RPLA 0. This one is no myo 0 because this doesn't supply the myocardium. And then we are not including this one because this one is really, really hard to see. So basically we only have one primary branch for the right coronary artery. So this is your model. It doesn't look very extensive because some of the branches are really hard to see, but you can see some of the main branches, right? Okay, so this is it. You can construct your model. You can say create model, select use all. That's okay. And it should construct your model if everything is good. Yeah, so we have the cap over too. Okay. Okay, so now I think the next step I think we should go over is in 3D Slicer, we want to be able to segment out the left ventricle in 3D Slicer that we can overlay on top of this one. Okay, so there's a left ventricle. So you have the left ventricle that sits right here along the LED branch. So I think we should just segment out the left ventricle. So maybe Anna can show us how to segment the left ventricle. Okay, Anna, can
so let's,
Yeah.
of course, yes. Let's just open up 3D Slicer. Let me just, are you familiar with 3D Slicer or should we go through this?
No, I think one thing I want to highlight is that when you load your images in SimVascular, it changes the units. So we should be loading the same image that we have in SimVascular. So is there a way we can load like a VTI image in 3D Slicer, or does it only load?
No, it only takes BTK.
Yeah,
But I suppose we can, you can load BTK on SimVascular as well.
oh, you can load VTK in SimVascular.
Yes.
Uh, okay, so let's how do we convert from VTI to VTK? What's the best way?
So right now I have a script that does this. Oh, actually we can use BMTK as well.
No, I think students won't have access to it. So I think the best way is just to go in ParaView and convert it. So I think if you want to show them how to convert VTI to VTK format, and so that we can load it in 3D Slicer. So the problem is that 3D Slicer doesn't load the images that we write in VTI format in SimVascular. So we want to convert it into a format that 3D Slicer can load. So Anna, if you open up your VTI image, so you can go in the synovascular folder. Yeah, so you go
So
in the
this is the synovascular folder, and we have the images here. I open image.vti.
press apply, and you just save it. File, if you go to file, save.
Sure, yeah. So save data. And
And
here, you change this to,
there's a VTK
does it
file.
have a VTK?
It's
Yeah, it doesn't.
go up, go up. It's right here, like the seventh
Oh,
one.
yeah, yes.
So just name, give it the same name, right? Image.
Image, that's specific.
So
I
now
press OK.
press OK. So all you did is just convert it to one image format to another, so we can load it in 3D Slicer. So now you should be able to load the same image in 3D Slicer. The problem is Synovascular doesn't allow you to segment very accurately the left ventricle. It's not really that easy. 3D Slicer is much more powerful for doing like threshold and painting over painting over an image. So you can directly segment out the left ventricle. So
Oh, so yeah, let me start from scratch. So on 3D Slicer, you can load the data. I just selected data. And you can either choose a directory to add or choose a file to add. So now I go with adding a file. You just go through this path. So again, on the synovascular folder, we have image.vti, and now we saved image.vtk as well. So it loads as a volume, which it should be, and press OK, it loads the image. So now here we can see the left ventricle. This is basically the way that you can place it is that you can see, and first you need to find the aorta, and left ventricle is connected to the aorta. So this actually is the left ventricle, and what you need to do is to go to the first a slide that contains the left ventricle, maybe here. So now VTK, oh, sorry, I'm saying VTK. 3D Slicer provides you with some tools as well as a segmentation editor. So you can find it here, segment editor. So you see that it named the segmentation as a new segmentation, and the source volume name was image. I add a segmentation, segment 1, we name it left ventricle. So if you choose paint here, it provides you with this paint that basically you can paint everywhere that you want to segment on the image. But so this is not the segmentation that we want. So let me just delete this. So one thing that you need to first understand is that what are the pixel values that we have in left ventricle. So let's just move my brush here around the wall of the myocardium, and at the same time, so I cannot move this, but on the left panel, you see a data probe on the bottom. And on the data probe, it shows you the location of the brush as well as the pixel value. So right now the pixel value is 112. So I'm just want to understand what is the range that the pixel value of the wall of the myocardium are changing in. So I have 105, 48. So you move it a little bit, and Then when you understood the range, which here we will choose 20 to 200, you come here. So I selected the paint, and it has this editable intensity range. I check this, and again, you put a lower threshold and an upper threshold. So I go with 20 to 200. So now this time, when I'm painting this, you see it only paints the areas that has a threshold in between, has a pixel value between 2 and 20. 20 and 200. So basically, it doesn't take the blood inside the left ventricle and also the aorta. Let me see, let me just. Okay, that's good. All right, so now I want to move to the first slide. So you see almost here, I still can see the left ventricle. I enlarge my brush, maybe 6% is good. So the areas that I can see the left ventricle, I just paint them and move on like for 3-4 slices. And again, do the same.
Anna?
Yes.
Oh, okay. Okay. I thought your voice disappeared, but you're just
I'm sorry.
we're talking and then all of a sudden you're not talking. So okay. No, that's perfect.
I'm just showing the student how to do this. So basically, we need to cover the whole, all of the slides in one of the anatomical planes.
Yeah. So I think one of the things you have to remember is you can only do this in one of the planes. So if you try to do this, like if you paint in one plane and then you go to another plane, like maybe a coronal or a sagittal, then you're gonna have then you won't be able to interpolate, right? So that's the key point. So if you start painting in one plane, like this is an axial plane, so you should continue in the same plane, because then once we interpolate, that's going to give us trouble. So it's not that, yeah, it's actually not that hard once you get a hold of it. It's just following a bit of step. Anna is being a bit more diligent by taking very small steps, but she's done these much more than I have, so I'll follow her lead. And as you can see, it's really hard. Like everything is bright, that's blood. And the tissues are a little bit hard to see, as you can see, right? Where the boundaries of the left ventricle is a little bit hard to see in these images. But hopefully if you pick the right thresholds, then you will be able to segment these more accurately. Okay. We're almost there.
We're almost at the aortic inlet. Halfway actually into the myocardium. Let's by now take a look at all of the planes. If you look closer into other planes, you can see that actually in other planes, you can see the myocardium and the segmentation that we have been taking. It doesn't show the segmentation very well because you're doing the segmentation every other, like every 4 or 5 slides. So again, let's maximize this and continue the segmentation. So this is the aortic valve. I can make my brush a little bit bigger, so much better. So I just made a mistake here and I included these parts as well. So my brush actually bent off, but it's all right. We're going to do the smoothing at the end. So I just leave it as is. Meanwhile, you can see the coronaries here as well. This is the left coronary coming out of the aorta. So now this is basically the connection between left atrium to the left ventricle, and you can see the valve in between them. Do you remember what was the name of this valve? The valve is open, as you can see.
Come on, folks, you
It's the
should
blood.
all know this, taking the course.
Is it the aortic valve?
No, this is the valve. So this is the blood inside the left atrium, and it is coming to the left ventricle. And this is the valve between the left atrium and the left ventricle.
Which valve is that?
What is the name of this?
Midterm is in 2 weeks, folks.
Is it bicuspid?
Mitral valve. Yeah.
Sure.
Yeah, this is the mitral valve, and you saw the aortic valve when you're segmenting the aorta.
So we're almost at the other end of the myocardium at this anatomical plane. So I continue as long as I can see and I can recognize the left ventricle. Oh, so that's it. Yeah. All right, so let's take a look at this. So you can see that at the other anatomical planes, we also have the segmentation. So now the next step is that we have segmented every like 4 or 5 planes. And we need to now fill in between these planes. So you uncheck this editable intensity range. It is really important. And you go to the smoothing filter here. So it is the smoothing filter, if you can see. So that is the third one from the bottom, on the left side, on the left column actually. So here you can have, you can choose the smoothing method. And the first method that I want to choose is to fill holes, closing fill holes. So that's it. You can play with the kernel size. Let's keep it 3 for right now. And again, you can see that the editable intensity range is unchecked. So I apply this filter and look at this. It actually filled the areas in between. So, but still I can see that there are some areas that it didn't fill. So it seems that the kernel size is too small to cover those areas. So I just increase it to 5. Let's apply this one more time. Much better. So now we have the whole myocardium. Let's look at this in 3D. Right, so we segmented the myocardium. It's not really smooth and a little bit. Maybe. Right, so the next step now is that we want to smooth this. For a smoothing, you can use either the median filter or the Gaussian filter. So let's try each one of them. Let's try the Gaussian first. With the Gaussian filter, you need to be a little bit more careful because it creates a hole inside the myocardium. So let's apply this. Okay, so it gave you a very smooth left ventricle, but look at this. It created a hole. So now you need to find where actually this hole is located inside the coronary planes. I go to the plane that I did the segmentation in. And I just move this up. Can you see the hole here? You see? I can place it. So one more time, I select my paintbrush. Again, I check the intensity, the editable intensity range. And I try to go to the first slide that this hole is started to. Okay, so this is almost the first slide. Maybe let me just rotate this so you can better appreciate this. So I start from one end of the hole and I go all the way to the end of to the other end. Just undo this and reduce the size of my brush. Okay, much better. I start filling the hole. Again, the same strategy. Every 3 or 4 slides, you just need to paint this. Make sure that the editable intensity range is still checked. So this image has been taken during the diastole. And so what happens during the diastole, do you know? What happens? What is the state of the heart? Is it pumping or is it relaxing? Alright, so we are almost at the end. And of course, you know that during the diastole, it is the time that the heart and the left ventricle is in a relaxation mode. So this is why actually the walls of the left ventricle are so thin. So one more time, I uncheck the editable intensity range and go back to the smoothing. I do closing fill holes one more time. Let's apply this. So not bad. All right, so now this time, one more time, I need to smooth this, but this time I won't go using a Gaussian filter because it is the filter that makes this hole. So I use a medium filter, and let's reduce the kernel size to 3 and apply this. Okay. Not bad, but as you see, medium filter is not as powerful as the Gaussian filter. So it didn't change this too much. One more thing that you can do is to actually check this apply to visible. No, sorry, this one. I was able to have this in 3D. Okay, so edit in 3D. And if you check this, here you have a smoothing brush option. And if you open this, there's this option that you can check edit in 3D. And then you can have your brush here in the 3D as well. So I can actually directly apply this just to the point I want to smooth it. It's just smooth here. And you can actually, you need to increase the kernel size a little bit. Okay, not bad. It's not as good as we want, but okay. Okay, so again, median smoothing created a small hole, but this time we do not need to go back to the image because it is a very small one. We can apply closing fill hole. And I just applied this on the 3D and you were able to close this. And if you want, you can continue smoothing the surface. But again, it creates the hole and you need to go back and forth. You need to go back and again, fill that hole in the image and do the process a few more times. But for now, I think this is enough. This is good. What do you think, Dr. Khan? It seems that Dr. Khan is not here.
Sorry, Anna, I'm here actually. I was just trying to find where
Oh,
my Zoom went. Okay,
okay.
yeah, this is perfect. Yeah, I think that's about it. It's got a few bumps in here and there, but this is the best you can get out of like a coronary CTA scan. It's not a cardiac CTA. Okay, are there any questions, concerns, comments, any feedback on how your segmentations are going? Any feedback for Anna and I on what to cover, what not to cover?
Is our goal to do like a full segmentation of like the entire heart structure and now like not just the coronary arteries, but the full heart structure?
No, so you mean full heart structure, you mean all of the atriums and the ventricles or just the left ventricle?
Yeah, that was essentially my question. Like, so are we now doing, because I noticed that we've added the aorta now. Are we adding that and the left ventricle and then that's it? Or are we
Yep.
doing all 4 chambers?
No. I think we should just stick with the left ventricle because it's really hard on a coronary CT scan to really see clearly like the atriums and the right ventricle because the walls are thinner and the coronary CT is probably not the best way to kind of segment these. But the reason where we are doing the left ventricle is because it kind of the majority of the left coronary artery feeds the left ventricle. So I think this is important structure for further analysis. So I think we are just gonna stick with the left ventricle. Aorta you can do in the SymVascular software. This is the only non-SymVascular software you would have to use for segmenting the ventricle. Yeah. So we're just sticking with the left ventricle. Any other comments? Kia, you have something?
Yeah, I had a question about the modeling, same issue from earlier. So I
Okay.
tried adding I segmented the aorta,
Yeah.
and this time I don't get the error regarding the not intersecting, but I still don't actually see the model. Like it says it was completed, but I don't.
Can you share your screen?
Yeah. So like I have the lofting preview, but without it, there's no.
So can you turn off all of the loftings?
Yeah.
Yeah, let's turn them off. Yeah, this is a good example. Okay, so let's turn these off. Okay, so go to the model and just press create model again at the top. No, you don't need to delete. Okay, yeah, that's fine. That's fine. Press OK. Yeah, I think there might be some can you move your 3D
Yeah.
screen around? Yeah, so I can already see there is some issue. So except for the aorta, you shouldn't see like you're
Is
seeing
it the red circle?
no, I think if you go in your face list on the right, let's see if we have all of the caps. Let me see RCA cap RCA1, cap RCA2, cap RCA0, branch. So you should have how many? You have 1, 2, 3, 4, 5, 6, 7. You have 7 branches, so you should have 7 caps. If you have more caps, then that's a problem. Let's see how many. 1, 2, 3, 4, 5, 6, 7. Can you check how many? Can you scroll on the left screen? Can you scroll up and see how many caps? How many branch? Okay, segmentations. Let's count the segmentations. You have diag 0. So no, just count the segmentations, please. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and aorta would be the 11th. So can you count how many caps you have on the right hand side? 1,
From 12 to 23, it's 11. No, it's 11.
10, 11.
All right, so it's not actually, one of the problems that could cause this is the caps. So sometimes is that your segmentation is not exactly, the starting segmentation of a bifurcation is not exactly inside the mother branch. So this is one of the problems that can cause this. But normally, usually it is like that you do not know which one of the segmentation caused this, unless we can see that you have a true cap for one branch. Other than aorta. So usually what I do to address this error is that press create model here. Okay, so uncheck all of them Use none. Okay. So select only a few of them, like aorta, LD 0, and then add a few of the LD branches, like maybe direct 0, direct 1, or maybe all of the LD branches, LD 0, LD 1. Okay. Now press OK.
Do I want LCX too or no?
No, that's all right. So this way, we want to see which one of the branch is causing the problem, and then we can select that branch when we understood which one is. Okay, so turn this. Okay, so now you have a model. So the problem is not within the LED branches. So create a model one more time. Now add LCX 0, RCA 0, and press OK. Okay, still you can see the model. One more time, create a model. And so now let's one by one add these branches because the problem lies within one of them. So add RCA 0 branch. Okay. So can we move the 3D? Okay, it was added. Yeah, very good. So create a model one more time. Okay, so it is either our RCA1 or RCA2. So add one of them. Yes, okay. Turn the, yes,
I
okay,
think it
so
was
this is
this one.
RCA1. Okay, so press undo. You want to go back to the previous model. No, you have undo on the top. You see on the top panel, right next to the Save as Fit project, you have an undo button. Okay, so now you have the model. So go to the RCA1 segmentation because this is the segmentation that is causing the problem. Double click and turn the lofting on. So one of the problems that might be is that the first segmentation is touching the surface of the mother branch. So maybe just make it a little bit smaller. Just a bit, yes. Okay, much better. And can you zoom in on the 3D segmentation? And turn it so I can better see the RCA one. Yeah, I don't think that any other problem is with this branch. All right, so let's go back to the modeling. And one more time, create a model. So now include RCA1. Okay. Right, so turn it. Yeah. Oh, still it's not working. So we need to repeat this. So one more time, go to the RCA. RCA1, so. Yes, and let's take a look at the second circle. Yeah, could you zoom in on the 3D model. So in a way that I can see the branch from the another perspective, like turn it around so I can see it from, yeah, yes, much better. All right, so now zoom in so you can see what's going on. You can hold shift at the same time, and yeah, that's much better. So you can place it in the center. And so it seems that the second branch is way more bigger than the first segmentation. So this could be one reason. I should just make it a little bit smaller. Just a bit. Okay. And another thing that it wouldn't make any problem in modeling, but in meshing it could be a problem that the segmentation of the, one of the circles of the mother branch is touching the surface or the bifurcation that is coming out of the RCA. Later on, this could make a problem. So let's again take a look at this. It seems that the vessel is somehow folded into itself. You see on the 3D model? Yeah, it seems that. Yeah. So actually for this problem, you need to modify the path line. So let's go to the path. Yeah, find this and yeah, RCA1, turn it on as well. Okay, go to the first path. And so on the axial, the red one, just go a little bit towards the proximal area, toward the stem of the RCA. Just move it a little bit. Yes, much better. Yes, no, not too much. It was too much. No, go back. One more time, go back. Yeah, here. So add another pass, another point inside the vessel, inside the RCA.
Should I just drag this one over or should I just make a new one?
Make a new one. Okay, add this and do the smoothing as well. Path points. Yes, okay. All right, so let's go back to the segmentation and see what's going on. All right, so circle one, take a look at that. Okay, so this is the very first slide of the segmentation. Maybe you can delete the first circle here and add another circle at the slice of 0. Just move it to the center of the vessel. It's just near the walls of the RCA. Can you move it to maybe another direction just to see how the vessel loft in preview changes? Yes. Okay, this is much better now. Okay, just save this. And one more time, try to create a model. Let's see. I think this time it is great. turn the 3D model just to make sure it is. Yes, okay, it worked. So we solved the problem. We can now one more time create a model with RCA2 included as well. Okay, yeah, yes,
Thanks.
that's very good. No worries. So welcome to Synvascular. This was a very good introduction to the error handling in Synvascular, and you're gonna get more of these kind of errors. So be prepared and buckle up,
Yeah.
actually.
Here I just have, this is a very nice segmentation of coronary arteries. For the aorta, I would recommend, there are a few things you can do. For example, when you're segmenting the aorta, so you have two segmentations really close to each other in the first one, so that's causing an abnormal looking geometry. So you can delete actually one of them. That's gonna smooth out. Okay, and the second thing you can do is like, if you go at the top, the second last one, right? The second last one, it's at a slanted. So that might just be because you probably haven't smoothed out the center line. So if you smooth out the center line, you shouldn't, if you look at your aorta center line, and if you smooth these out, then it shouldn't create these kind of slanted looking, I don't know what we had picked. And then if you go back to your segmentations and maybe delete that one and create one at the bottom, yeah. And maybe delete the second last one. Yeah, and maybe just create a new one there. Close to it, yeah, if you scroll up. Yeah, if you create a new one. No, go up, go up. Oh, yeah, I don't know why it's twisting that way.
The image kind of cuts off, so there's like a.
Yeah, that's okay, but if you come down, it shouldn't.
Maybe you need to smooth the arrow to pass. Did you smooth it?
Yeah, he did smooth
Yeah, I
it.
just.
You did it? Oh, okay. Sorry.
But that's okay. It's all right. But as long as you smooth and you should be able to create a much smoother looking aorta. Yeah, it shouldn't. Maybe it's the point is not. Yeah, so this kind of, this kind of noise is not good, but that's okay. It looks all right to me otherwise. I just, it's like sometimes it's just you just want to finesse it a little bit, but otherwise this looks nice. This looks very good to me. If any of the students actually see a plaque, which means if you're segmenting and you see a bright spot, please let us know for next time and we can use that as a demonstration for other students as well. All right, everybody, I think that's about it for this week. Unless you have any comments or concerns. If you're all okay, then I'm okay. So how many, has anybody gone past first case? Thumbs up if you've moved on to case number 2. Okay, I have 1, 2. All right. Okay, so that's okay as long as I think the first one takes a bit of time, but once you get through first few of them, you should all be kind of crunching these in like a matter of 1 hour or something. Okay, everybody, thank you very much. I'll see you all next week then.
Have a good day.
Take care, bye. Bye.
Bye. Dr. Han?
Yeah, all right. Thank you very much, Anna. This is really helpful.
No worries.
Oh, let me.